This is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to discuss a topic called as importance of petrology. So what is importance of petrology? That we are going to discuss today. So petrology is it's a type of, or it's a branch of geology. So as we have discussed in the previous lectures about geology, the physical geology, and the importance of geology as a civil engineering point of view. So today we'll be discussing, which is a part of engineering geology, that is called as petrology. So in petrology, we will be discussing about types of rocks, different types of rock formations, their history in the previous era, in the history, what type of rock was formed, what kind of fossil fuels were present in the different eras. So that we'll come to know, and this all we will discuss in the today's lecture. So let us start with this lecture today. So importance of petrology in this introduction, if we see. So what is petrology? So petrology is the scientific study of rocks. So as we have discussed in the previous lecture about the physical geology, in physical geology we have studied different kinds of rocks and minerals and types of earth materials, the presence of materials on the earth's surface, how it is helpful in the construction point of view. So same thing, like if you talk about petrology means we are studying about different kinds of scientific rocks which are helpful in the construction field, as well as what is their origin, how they are originated, their composition, what is the main composition of that rock, and structure and transformation process. So structure and transformation process means we have to just know about the type of the rock. First of all, origin means what is the origin of the rock. So as we know, there are three types of rocks. So in the physical geology also we have studied, there are three types of rocks. One is igneous rocks, sedimentary rock, and metamorphic rock. So how does these kind of rocks are formed? What is the origin of these kind of rocks? That we will be studying. So their composition, as we know that in the previous lectures also I have discussed with you that rock is a composition of different kinds of mineral. So rock has a different kinds of mineral present in that. Like suppose one rock is a igneous rocks or sedimentary rock or metamorphic rock. It can contain either one mineral, either two mineral, either three minerals based on its composition and origin. So from where it is originated, either it is originated through magma, originated through lava, or originated through the sediments. So based on that, the origin will be decided, and based on that, the composition of the rocks will be described. And what is the structure means? Basically, what kind of texture it has, what is the look it has, what kind of glassy texture or a very fine texture or a coarse texture, which kind of texture it has, that all we study in the petrology. And transformation process, because as we know there are three types of rock: igneous rocks, sedimentary rocks, and metamorphic. So metamorphic is the rock which has a transformation process. So the rocks which are already formed, like in the form of igneous rocks, already formed as a type of sedimentary rock, it goes through the heat and pressure. When it goes through the heat and pressure, then finally this metamorphic rock will be formed. So this all information we will study in this petrology. So basically petrology is what? Petrology is the study of rocks, their origin, their composition, their structure, and the transformation process. It plays a fundamental role in various fields, from geology like and engineering to environmental sciences and resource exploration. So it gives us the main information about the different formations of the rock process, its origin, and like in the various fields, it plays a very important role in the various fields of geology, various fields of the engineering part, environmental sciences, and resource exploration. So the study of Earth history and geological process helps us to comprehend how the planet has evolved or over billion years. So as we know, our planet is a billion years ago, it was very long years ago, it was formed. So the formation of the planet, the movements of the plate, the tectonic movements, how the planet is formed. So that all study we do in this petrology. By analyzing the rocks, fossils, geological formations, scientists can reconstruct past events and predict future changes. So we analyze the rocks, analyze the fossil fuels, geological formations, and the scientists how they reconstruct the past histories and the events and how they predict the future. That all we can discuss in this petrology. Now, what are the scientific study of rock? When you talk about the scientific study of rock, when you talk about different kinds of rock, so as I told you, we are having three types of rocks. We call it as a scientific study, we call it as igneous petrology. So igneous kind of rock, when you study about the igneous kind of rock, we call it as igneous petrology, sedimentary petrology, metamorphic petrology. So what is igneous petrology? Igneous petrology is study rocks formed from solidified magma or lava, solidified magma or lava. So in the previous lecture also I told you there are two different kinds of rocks which are formed either by the magma, either by the lava. So lava and magma both are molten material. So they both are molten material. So either this material, it will be in a molten condition underground. So these molten material, what happens when it solidifies inside the earth surface, it becomes as a magma. So same magma material when it erupts as a form of volcanic eruption, then it becomes as a lava. So these two types of rocks, it is formed by the as a igneous rocks. So in petrology, when you study about the igneous petrology, studies the rock formed from the solidified magma or lava. So either the rock is formed from the lava or the magma. So what are the different examples of lava and magma? Here is basalt and granite. So basalt and granite are the two types of different kinds of rocks. We call it as igneous rocks, which are formed by either magma or lava. Now sedimentary petrology. What is sedimentary petrology? It examines rocks formed from sediments or accumulation and lithification. So these kind of rocks from a small like a coarse sediment or a very fine sediment. So these are the forms of sediments which are accumulated. It accumulates at one place and slowly it forms a rock. So here if we talk about examples of the sedimentary rock, we have sandstone and limestone. Sandstone and limestone these are the examples of sedimentary rocks. So in the sedimentary petrology, we study about different kinds of sedimentary rocks, their origin, their formation and all. Now if we talk about metamorphic petrology, so metamorphic petrology, this is the kind of rock which is formed by the heat and pressure of the transformation process. So metamorphic petrology focuses on rocks so that have been transformed by heat, pressure or chemical process. For example, marble and schist. So these are the two basic examples of metamorphic rock, or through metamorphism these are formed, like marble and schist. These are the two examples when the due to the igneous rocks or the sedimentary rock goes through the heat and pressure. After this heat and pressure, these rock formations are formed like a marble or schist. Now let us understanding the earth history and process. So as the importance of petrology, why we need to study the petrology. So let us understand the history and process. So under the understanding the history and process, how the earth was formed and when the earth was formed, about its time scale, about the rock records, about the different kinds of fossils. When you study about the evidences in the previous history, then we'll get to know about the evidences of the previous rocks. Now help in reconstructing the geological history of the earth by analyzing the rock formations. So it will help us, understanding the earth history will help us in reconstructing the geological history of the earth surface and by the analyzing the rock formations, and it provides insights in plate tectonics. Now what is plate tectonics? So our earth is now how our earth is looking like this. Before it was not like that. It was a single continent and there are plate boundaries. in the continent, there we have different plate boundaries. So these plate boundaries are like this, and these boundaries are keep on moving at the speed of 10 centimeter per year, and these boundaries will be keep on moving, and once they collide with each other, then suddenly these natural disasters will occur, like earthquakes or volcanoes or tsunamis. So plate tectonics are like provides insight into plate tectonics, volcanic activity, mountain building process will happen. So when you understand the history of the earth, in the history, the mountain formation due to the volcanic activities, due to the plate tectonic activities, these all mountain formation will process aids in understanding the past climate changes through the sedimentary rock and the records. And the rock, under this understanding the earth history and processes, we have this the rock record and the geological time scale. So what is rock record and the geological time scale? So rock acts as a time capsules. So it's the rock is like itself is like a capsule because it contains lots of information in it. Because rocks has a minerals present in that, the fossils present in that particular rock will tell us about the time scale. Like it tells us about the history of the earth surface and history of the species present in different eras. So which preserves the evidence of past environments, climate changes and tectonic movements. So these kind of rocks will preserve the different kinds of climatic changes, the environmental changes, the evidences and the tectonic movements activities, because the rocks, that's the reason the rocks acts as a time capsule. And the geological time scale is divided into eons, eras, epochs, helping the geologist date and correlate the rock layers globally. So they will just correlate the global layers orally, and they will just get to know about the different kinds of periods or eras in the different time. Now, if you see this figure here, we have as a geological time scale. This is a geological time scale. So if you check about the different eras, now the present condition is this is our present situation. We call it as epoch era. So in this we have Quaternary, Tertiary or Cretaceous, Jurassic era. So we have Cenozoic era. We are in the Cenozoic era. So before it was Mesozoic era. In this Mesozoic era, you can see the dinosaur species were present over that time. So in this all eras, like this all era is having different species. When you see the present era is have a different species here. Now, if you check about this Paleozoic eras, Paleozoic era, we have different this kind of species, like earliest like land animals were there, or something like early fishes were there. Cambrian era. So these are the species. These are the different species in this Cambrian era or Ordovician era. So this was 450 billion years ago, 500 billion years ago, 550 billion years ago. So this was the condition of the earth surface when you talk about the geological time scale. So we were having this kind of species previously. Now at the present situation, we are having our condition is epoch era, the humans and the elephants and all in this era. So this is just 2.8 billion years and this is 0 years. So this was about the time scale in the geological time scale in the previous eras, what was the species present over there and kinds of the activities are taking kinds of fossils. Based on the fossils, we are able to identify the different kinds of species present over there. So that's why we call it as rocks acts as a capsule, because it tells us about the history of the different species in the previous eras. So this was the condition formation of the earth. So this is the first condition, which was about 4,540 billion years ago. So this was the condition of the earth. Now if you talk about 4,000 years ago, 4,000 years, billion years ago, so billion years ago, this was the species present. Now 550 billion years ago, in the 450 billion years ago, there was this many species. Then the Jurassic Park era came, and this all the dinosaurs were present over there. Now at the present situation, these all species are vanished. Now present situation, we have this humans and animals present in this era. So this is the time scale. When you talk about petrology, when you study about the different types of rock. It will tell based on the types of the fossils which are present in the rock itself. It will tell you about the different history of the earth, or history of the eras, like how much long years or how much old these rocks were formed. Now, next thing is plate tectonics and continental rifts. First thing what we have studied here is about the rock record in the geological timescale under the understanding the earth history. So this we have studied about the geological timescale, about the earth record, rock record. Now we will talk about plate tectonics and the continental drift. Now here plate tectonics and the continental drift. So this is the different theory here. So what is a plate tectonics? So as I told you, the entire earth surface is divided into different boundaries, right? These are the boundaries like this. So these boundaries we call it as plate boundaries. Okay, plate boundaries. These boundaries are known as plate boundaries, which has a different kinds of boundary here, and these boundaries will be continuously moving at the speed of this boundary will be tectonic boundaries. We say tectonic boundaries will be moving at the speed of 10 centimeter per year. Okay, 10 centimeter per year. So these movements will be very slow. So while moving these, what happens is when one plate, suppose these are the plates 1, 2, 3, 4, 5, 6 or 7 plates are there. When it is moving apart or when it is colliding, so at the moving apart or colliding, what happens? There are the events like disaster occurs, like volcanic eruption may occur, tsunami may occur, earthquakes may occur. So these boundaries will be continuously moving. So movement of earth tectonic plates has shaped the continents, earth basins and the mountain ranges. So because of this movement of tectonic plates, wherever it collides or wherever it's moved together or moves apart, so there at those boundaries, wherever these plate boundaries are there the mountain formations and any kind of valley formation, ridges formation. So different kinds of geological structures will be formed. Faults, folds, faults, or any kind of unconformities. So these all kind of structures will be formed based on the tectonic plates. So tectonic plates are the plate boundaries. The whole entire earth is divided into different plates, and these plates are moving continuously. So when it collides with each other, then these all disaster activities like earthquakes or tsunami will occur. At that moment itself, this formation of mountains or formation of different geological structures will be formed. Now, plate interactions cause earthquakes, volcanic activity, and the formation of new crust. So it may form a new crust, and mid-oceanic ridges also it may form. So understanding plate tectonics helps geologists to predict natural disasters, locate resources like minerals and petroleum. Now, plate tectonic is a scientific theory that explains us about how major landforms are created as a result of Earth's subterranean or terrain movements. So the theory which will tell us about the solidified into 1960s transformed the Earth sciences by explaining many phenomena including mountain building events and volcanoes and events. So this plate tectonic theory tells us that there was a single continent with a different plate boundaries. So we call this as a single continent named as Pangaea. Okay, named as Pangaea. So this single continent was slowly moved apart. So as I told you, the plate boundaries are continuously moving. So it has slowly moved apart. Okay, so moved apart. So what happened at the present situation, the continents what we see here is that is due to the plates has moved apart and it has separated from the plate boundary. Suppose here was the plate boundary, it has separated now. Now it has a gap between these two boundaries. Suppose this is one boundary and this is one boundary. So this was first joined together, because of the movement. Now it has detached from one boundary to the other boundary. So in the plate tectonic theory, says that, so before there was a single continent, slowly the continent is divided into 7 supercontinents. So because of the plate movements, and what is the proof of that is, when you check the fossils of these regions, fossils of this continent, and this continent, when you check the fossils, this continent and this continent fossils will be similar. Okay, you have a similar fossils because it was joined before, later it has moved apart. So when you try to join, it will look like a jigsaw puzzle. Nowadays, the world map, what we can see here, we can see the different continents which has moved apart already. When you try to bring together, when you try to bring all the continents together, it will fit to each other. The boundaries will fit to the other continent. So that is a proof in plate tectonic theory. It says that that was a proof that before the continent was a single continent, now it has moved apart and it has become a different continents here. So in this theory, it will tell us about the movements of the plate, about the different continents has moved apart. Now plate tectonic, as I was telling you about plate tectonics, so the plate boundaries in the earth surface, as I told you, these are the plate boundaries. So these plate boundaries are continuously moving. So they are moving as subduction, lateral sliding, spreading. So they move like this. So suppose this plate and this plate is moving. So either the subduction will take place, it will go inside from here, it will come up inside. So subduction will take place, and here lateral sliding may occur. Lateral sliding means this boundary will go this side and this boundary will go this side. So at lateral moving, what happens? It is colliding to each other. Both are colliding to each other. So once it collides to each other, at that time, what happens? The area over here, the chances of earthquake, chances of volcanic eruption or tsunami. So these kind of disasters will occur in these regions, So with this spreading or the subduction, the formation of mountains may occur. Okay, formation of ridges, formation of mountains, formation of valleys, and this is one more type of movement. Like this is a plate boundary. So it will occur, it will move apart, either it will go here, either it will go here. So this type of sliding will occur when the plate will collide with each other. Now we have a destructive plate figure here. Now if you talk about this continental crust, so we have a continental crust layer as a layer of the earth's surface. Then we have lithosphere, then we have atmosphere. So this is how the formation of the destructive plate looks like. Now, fossil record and evolutionary history. When you talk about the fossil record and evolutionary history, fossils preserved in the sedimentary rocks. So when you talk about the sedimentary rock, sedimentary as it is formed by the different fossils. So once the fossils are gathered together, when it is decomposed at one place, slowly it is accumulated at one place. So fossils preserved in the sedimentary rocks provide the clues about the past life. So what is the past life? In the past history, what was the condition, what type of species were present, forms the helping the scientist to trace the evolution. So scientists who are doing research on these fossil fuels and doing research on the rocks formation, they will just trace out the information, they will just find out the information, types of species present over there. With that clues, they will get to know that how much older is this rock. Because of the fossils which are present in that rock will tell us that if we find a fossil of dinosaur, so that means that kind of rock is formed at the time of dinosaur age. So dinosaur age was the age, Jurassic age, as we have seen in the previous here. This was the Mesozoic age, and it was the Jurassic age where this kind of rocks were formed. So if you find this kind of fossils in this, that means that that kind of rock is in that era. That means the age of the rock we can just get to know with the fossils record. Now fossil evidence supports major events such as mass extinctions, climate shifts, species adaptation over the millions of years. Now second thing is resource exploration and economic geology. So under the petrology, we just study about the resource exploration and economic geology, essential for discovering the extraction valuable resources such as minerals. So why the importance of petrology is there in economic or the resource exploration also? It is essential to find out the different kinds of metals present in the rock, even in the oil drilling or something like coal mining and natural gases resources. Also, if you want to just find out these resources also, we should study about the petrology. Assist in identifying economically viable rock formation for mining and quarrying. And resource exploration and economic geology focuses on identifying, evaluating, extracting valuable earth materials. So it will help you, the resource exploration and the economic geology, that is basically it focuses on identifying the minerals, evaluating the minerals, extracting the valuable earth materials such as minerals, such as metals, such as fossil fuels, and the groundwater too. Now, what is the economics importance of economic geology here? So, importance of economic geology, if you see, economic geology studies the formation and distribution extraction of natural resources, which contribution includes identifying valuable minerals, energy sources, gold, iron, petroleum. As an economic point of view, if you talk about petrology as an economic point of view, it will tell us about different sources. It will tell us about the different kinds of metals or the economic minerals which are very important in nature to find out, like gold, iron, petroleum, coal, uranium, etc. Supporting the industrial development through the material supply for the construction, manufacturing and the technology. Now, aiding the sustainable resource management by analyzing the environmental impact, the extraction feasibility. Now, third thing, let us understand here, engineering and construction application. So, why do we study the petrology as per engineering and construction applications? So, as per the engineering and construction applications, the study of extraction of earth materials play a crucial role. It plays a very crucial role in engineering and construction field by providing the essential resources, as it provides the essential resources for the construction works, for the infrastructure purpose, for the developmental purpose, for ensuring the site suitability, site stability, mitigating the geological hazards. It can help us to mitigate the geological hazards because it will tell us about the different histories of the rocks and the stability, the durability of the rock. Because the formation, if we talk about rock formation, what kind of minerals are present, if the minerals are very soft kind of minerals, if the rock is having 2 to 3 types of minerals which contains soft kind of minerals, that is not durable for the construction work. So how durable it is, that all information can be gathered before we go for the construction work, and which can mitigate the geological hazards or reduce the geological hazards in future. So used in assessing the strength, durability, stability of the rocks, it will help us to find out the durability, and it will help us to how stable the rock it is, and the infrastructure projects like tunnels, dams and roads, because the whole construction is the whole economy and the whole construction work, it totally relies on these kind of construction buildings, that are tunnels, dams, roads, bridges, which connects to each other. So before going for these kind of huge projects construction, a geologist, a civil engineer should know about the type of the rock, the history of the rock, and the presence of minerals and the presence of material, the organic material which is present in the rock, which rock is going to use for the construction works. So it will help us, once you study the petrology, it will help us to know about the presence of different compositions of minerals in the rock, and helps in evaluating foundation conditions for the buildings and the other structures. Now, if you talk about rock, soil and rock classification and as a geotechnical purpose, so as a soil rock classification for geotechnical purpose, it plays a very key role for classifying soils and rocks based on their composition, based on their texture, based on the mechanical properties. It is important for the geotechnical engineering and the civil construction projects. So once we study about the rock, once you study about the petrology, it also tells us about the formation of the soils. So which type of rock, if you talk about igneous rocks, Then what kind of soil we receive. If you talk about sedimentary rock, what kind of soil we receive. And the soil, basically it is formed by the rock only, the weathering of the rock process. So whenever the weathering takes place in a igneous rocks, weathering takes place in the sedimentary rock. So that all depends what kind of soil is present on a site wherever the construction work is going to be taken up. So this is how it will help us in a classification of a geotechnical process purpose. Like before going for the construction projects, we can just know about the type of the soil, the durability and the flexibility of the soil, and we can just use the mitigation measures based on the type of the soil. So that's why it's very important as a geotechnical purpose also for the construction works. Now let us know about the environmental and hazard assessment. When you talk about environmental and hazard assessment, helps to predict and mitigate the natural hazards like earthquakes, volcanic eruptions and landslides. How it will help you? Because once you know about the type of geology structure, either the fault is present, fold is present, unconformities is present, or type of the structure, the type of the soil, type of the rock which is present over there, which will predict and mitigate before itself once the hazards or natural disasters are going to be occur. So because earthquakes are the natural disaster, this will occur always in the near the fault line zone. So these all zones wherever the fault and the fold line zones are present, see these are all comes under the vulnerable zones of the earthquakes. So landslides means the type of the soil it has, the type of the rock, the durability of the rock it has. That all depends on these kind of destruction when it happens, whenever this disaster may occur. So this will help us to reduce the disaster. This will help us to mitigate the disasters. So using groundwater studies to determine the aquifer properties and water availability. It will also help us to tell us about the groundwater studies. It will determine the aquifer and the properties and the water availability at any site at underground or nearby areas. So assist in assessing the pollution and contamination risk in soil and their formations. Now, when you talk about the advancements in science and research, so as a study of this petrology, it is also important in the fundamental planetary geology, aiding the study of rocks, moons, Mars and the other celestial bodies. It contributes to material science, including the development of the synthetic materials based on the natural rock properties, and even in integration with the modern technology. So when you integrate with the modern technology, it also works alongside the geographic information system, and when you integrate with this geographic information system with remote sensing for the better geological mapping. So when you integrate this modern technology in this petrology studies, it will help you to tell us about the different kinds of sites present wherever this geological mapping is done. So remote sensing and GIS will help us in the digital information providing and sitting at one place. So enhances the automation and the rock classification system, which aligns with the project on the soil and rock classification systems. So these are the few points when you talk about the importance of petrology. So we have to consider these all points, and we have to understand as a construction point of view, as a geologist, as a civil engineering point of view, as a stability point of view. We should know about the rock structure. We should know about the type of the site, type of the soil present at any site. This will help us to understand this kind of site present at any construction site, so that in future there is no failure chances, and we can just mitigate the failures or mitigate the problems over that site. So these are the few references which you can just go through to find out more content about this importance of petrology, importance of the petrology study. You can go with the engineering textbook of engineering geology, Macmillan India by Keshavlu, or Venkat Reddy, Engineering Geology by Vikas Publications, and we can just go through this Vasudev Kyaniti. So these are all different references you can just go through to find out the more content about the petrology. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.